Hello friends, today we will start new chapter number 6 from second section, combustion in CI engine. The previous 4 lectures we studied combustion in SI engine. So again the same content that we have to discuss in chapter number 6 that already we are discussing in SI engine. Only the parameters are going to be changed in this case. So see the syllabus content: stages of combustion, delay period, factors affecting delay period, abnormal combustion, diesel knock, influence of engine design and operating variables on diesel knock, cetane number, comparison of abnormal combustion in SI engine and CI engines, requirements of combustion chambers of the CI engines, and introduction. As we know that in SI engine, uniform air fuel mixture is supplied by the carburetor, means homogeneous air fuel mixture is prepared by carburetor externally, which is supplied to the SI engine. But in CI engine, air fuel ratio is not homogeneous. Fuel remains in liquid particles. Only air is to be compressed and fuel is injected over this compressed air. And therefore, we need more amount of that air compared to the SI engine. Means almost 80% of air it should be more compared to the SI engine, means more than stoichiometric mixture, means almost lean mixture is to be needed in case of CI engine. Same time in SI engine, the combustion starts at one point and the generated flame by the spark plug at the point of ignition propagates through the combustion chamber through the mixture for the burning of this mixture, and thereby the pressurized curve is smooth in case of petrol engine. But in case of CI engine, the combustion takes place at number of points, at the number of that points simultaneously. Getting it is a simultaneously, means number of flames are generated, means number of these hot spots are generated, number of such hot spots are generated, and which are going to burn the fuel more and more. Getting, so whatever the pressure rise, that is a rapid, that is uncontrolled in case of CI engine compared to the. So stages of combustion in CI engine or P theta diagram, pressure crank angle diagram, that we have to study. So the combustion in CI engine takes place in 4 phases or 4 stages: ignition delay period or pre-flame combustion, uncontrolled combustion, controlled combustion, and after burning. So in SI engine there are ignition delay period, flame propagation, and after burning. But in this case there are 4 phases: ignition delay or pre-flame combustion, uncontrolled combustion, controlled combustion, and after burning. Here what happens, the delay means start of injection is before TDC, it is before TDC, and combustion is also start before TDC. So in this way the delay period that is shown on pressure crank angle diagram between points A and B. Point A represents the time of injection, point B represents the time of combustion. So ignition delay period can be divided in 2 parts: physical delay and chemical delay. So delay period is very much important because it exerts a great influence on both engine design as well as engine performance. Getting, so it is of extreme importance because it affects on both combustion rate as well as on the knocking. Also it will influence on the starting ability of the engine as well as the emission of the engine. See the delay period, ignition delay or ignition lag. So delay period is the time between start of injection and start of combustion. So if you see, the delay period extends for about 13-degree movement of crank. We will start the delay period before TDC, and how much, that is around 13 degree of the movement of the crank, during which the delay period is going to be existed. So this delay time decreases with increasing speed. As speed increases, delay time decreases. If there is no delay period, Getting, if there is no any time interval between the start of injection and start of combustion, mean what happens? The fuel will going to be burned at injector. Getting, fuel will burn at the injector only, and what happens? There should be a oxygen deficiency around the injector, and that will result in an incomplete combustion. It will result in an incomplete combustion if there is no delay period. Meaning, because of there is no delay period means start of injection and start of combustion. There is no any time, so fuel will be burned at the injector only, and because of that, the fuel that is at the injector is going to be utilize the air, utilize the oxygen around the injector, and in that way there is a deficiency, there is an insufficiency of the oxygen around the injector. Getting, so if the delay period is too long, if the delay period is too long, then amount of fuel availability for simultaneous explosion is too great. If delay period is long, more amount of fuel is to be accumulated, more amount of fuel is admitted, and that will cause the simultaneous explosion is too great, which results in rapid pressure rise. So the delay period should be as short as possible, since long delay period gives the more rapid pressure rise, also it causes the knocking. So here components of the delay period or ignition lag or physical delay. So physical delay is a time between the beginning of injection and the attainment of chemical reaction conditions. Getting, so delay period is divided in two parts. Physical delay means that is a mixing period, during which the mixing is to be going on of the fuel and air, as air is highly compressed and fuel is injected over this highly compressed air. So in that way the fuel is atomized, vaporized and mixed with air and rise to its self ignition temperature, but not yet ignited. Getting, it is only to be prepared. This is only the mixing period. So again it will depends upon the type of the fuel, where it is a light fuel means where it is a highly volatile fuel, or it is a lower volatile fuel means heavy fuel, means light fuel or heavy fuel. Accordingly the physical delay period is there. For again it is obvious, for light fuel delay period is a small, physical delay period is a small. For heavy fuel physical delay period is a high. So the physical delay period is greatly reduced by again high injection pressure, because with the high injection pressure it will results in better atomization. Getting, it will be better atomization, rapid mixing of air and fuel. Getting, with the high injection pressure it will break the fuel in small that droplets, fuel particles. So by that way high injection pressure also reduce the physical delay period, as well as high turbulence, whatever the motion of the air inside the combustion chamber, inside the cylinder, that also going to be mixed, that is required for the better mixing of air and fuel. Getting, and by that way it will improve the evaporation of the fuel. Getting, if fuel droplets is a very small, then it will be easily evaporate and mix with the air. That's why this physical delay period is a mixing period. It is a mixing period during which the fuel and air has to be mixed, and they are going to attain the chemical reaction conditions. Means after this the chemical reactions are going to be formed. Then chemical delay period. So during the chemical delay, reaction starts slowly, then accelerates until inflation or ignition takes place. Means during this phase the chemical reactions are start slowly and then it accelerates until the ignition takes place. Means once ignition takes place, till this delay period is proceeds. So generally chemical delay is larger than physical delay. So total delay period is equal to physical delay plus chemical delay. In the examination they ask the short note on the delay period, physical delay as well as chemical delay period. In SI engine the physical delay period is almost zero. Physical delay period is almost zero, because in SI engine the fuel is highly volatile compared to the diesel. Getting fuel is highly volatile. That's why the mixing is already, it is a uniform or homogeneous mixture is to be formed. Same time it is also a high volatile fuel. High means it is light fuel. That's why the physical delay period is almost zero in case of SI. Now second phase, that is the period of rapid combustion. So during the period of rapid condition, what happens, how much fuel is to be accumulated in the combustion chamber. Getting, so during the delay period, during this time interval, the considerable amount of fuel is admitted in the combustion chamber or accumulated in the combustion chamber. So this admitted fuel droplets burns very rapidly and causing the steep pressure rise in the indicator diagram. Means highly that pressure rise, you can observe high pressure rise with this phase, during this phase, and that's why it is called the uncontrolled combustion. That's why it is called the uncontrolled combustion. So the period of rapid combustion is counted from end of delay period or beginning of the combustion, means start of the combustion. It is from the start of the combustion, means where you can found the period of rapid combustion. So this is known as the uncontrolled combustion phase, because it is very much difficult to control the amount of burning or injection during this process of burning, because during this phase already fuel is admitted inside the combustion chamber. Also injection process is going on. As this injection process is not ends, it will be ends after TDC. Because of that it is uncontrolled, there is no any control over this combustion phase, and that's why the rapid pressure rise will going to be occur during this phase. So it may be noted that the pressure reached during the period of rapid combustion will depend upon the duration of delay period. It is obvious, means longer delay period means more amount of fuel is admitted, more amount of fuel is accumulated, and higher pressure will be observed inside the combustion chamber in the cylinder. And that's why the longer delay period results in a rapid or uncontrolled that pressure rise. Third phase, that is a period of controlled combustion or control by controlling rate of injection. So as we know that injection is going on during the period of uncontrolled combustion also, but this injection of this fuel will be ends after TDC, during the phase 3. The rapid combustion period is followed by the third stage, the controlled combustion. The temperature and pressure in the second stage is so high that fuel droplets injected burn almost as they enter and find necessary oxygen in the combustion chamber. As during this phase the injection is to be end, and that's why here during this phase we are going to control the combustion. During this case we are going to control the combustion, as injection is going to be ends during this phase. So once, however, whatever the fuel is to be admitted, whatever the fuel is to be coming inside the engine cylinder is immediately going to be burned once it found the necessary oxygen. So the period of controlled combustion is assumed at the end of the maximum cycle temperature. Period of uncontrolled combustion, that is a end to the maximum pressure in the curve. This end at the maximum temperature. Then fourth, period of after burning. Combustion does not stop with the completion of injection process. Similar to SI engine. In SI engine also combustion is not stopped, but the pressure rise is not to be going to be happen in that after burning phase. In the after burning phase, because in case of SI engine also we discussed that the flame speed is to be reduces in the SI engine, and as flame speed is reduces the pressure is also declining. So in this case also only during this phase whatever the unburnt or partial burnt fuel which is left in the combustion chamber are going to start the burning as soon as it come in contact with the oxygen. If they are going to find the oxygen, these unburned particles or partial burnt fuel particles, they are going to be burned. Getting? So this process continues for certain duration called afterburning period. Usually this period starts from maximum temperature in the cycle and continues over part of expansion stroke. Getting? Part of expansion stroke. So generally this afterburning period is going to be start after the 72 or 80% of crank travel from TDC. After TDC 70 to 80% of crank travel, it is going to be starts this afterburning period. So in this way, these are the 4 phases proceeds in combustion of CI engine. So here we will discuss the combustion in SI engine and combustion in CI engine. Differentiate between the combustion in SI engine and CI engine. So in SI engine, homogeneous mixture of petrol and air is compressed at the end of compression stroke and is ignited at one place by spark plug. Correct. In case of CI engine, only air is to be compressed. Only air is to be compressed. Fuel is injected at high pressure around 200 bar using the injector pump. Getting? That is the first difference. Second, in SI engine there is a single definite flame which is initiated by the spark and it propagates in the mixture, and entire mixture is to be burned by that single definite flame. But in this combustion chamber in CI engine, there is no such flame. There is no such a single flame. Only fuel is not injected at once, but it will be spread over a period of time. As we are knowing that start of injection is at point A in the indicator diagram, and it will injection period it ends after the TDC. After it means during the controlled combustion phase, the injection is ends. Getting? So injection is not at once. It is not at once. Getting? But it will be spread over a definite period of time. And because of that, there is no single flame is there. Instead of that, there are different hot spots that will be created in combustion in a CI engine. Third one, that is for effective combustion in SI engine, turbulence is needed. Already we have discussed. Turbulence is needed. Moderate turbulence is needed to accelerate the reaction, to accelerate the combustion. Getting? Because turbulence which is required in SI engine implies that it is a disordered air motion with no general direction of flow to break up the surface of flame front and to distribute these threads of the flame throughout the homogeneous mixture. Means turbulence is not having the ordered motion. It is a disordered. Getting? It is a disordered, and this disordered motion is going to break up the flame in a different that small flames, and they are going to be spreads in the combustion chamber in this homogeneous mixture. In CI engine, for effective combustion, swirl is required. So swirl and turbulence, that again we have to discuss, that is in details. But here also just a see. The swirl means that is ordered motion. Turbulence means disordered motion. Getting? Turbulence means disordered motion. Swirl means ordered motion. There is a definite order for the swirling motion, and because of that, what happens? Orderly movement of this air with the particular direction of flow, it will brings the continuous supply of fresh air to the fuel droplets. Getting? It going to be supply the fresh air to the fuel droplet. At the same time, they are going to be helpful to sweep away the products of combustion. Getting? Otherwise it will be suffocates, means it will going to be stops the combustion. Getting? So in this way, in SI engine, turbulence is to be effective. In CI engine, swirl is to be effective for the effective combustion. Then in SI engine, ignition occurs at one point with slow pressure rise. But in CI engine, ignition occurs at many points at various locations, and because of that, it results in a rapid pressure rise, uncontrolled pressure rise. Getting? Because there is no definite flame. Correct? Next, in SI engine, physical delay period is almost zero, and chemical delay period is going to control the combustion. In CI engine, physical delay period controls the combustion because it is a mixing period. Getting it is a mixing period, and that will going to control the combustion. Last, delay period that is desirable for SI engine is a longer delay period and high octane fuel required. Getting high octane fuel required. Delay period must be short as possible. High cetane fuel is to be required. So short delay period is required in case of CI engine. In case of SI engine, longer delay period is required. High octane fuel, high cetane fuel. So it is about the combustion, comparison of combustion in SI engine and CI engine. Now see the effect of various factors on delay period. How the various factors are going to affect the delay period? It means with these parameters, whether delay period reduces or increases, that we will discuss one by one. So here we are considering different factors: compression ratio, engine speed, output, injection timing, quality of the fuel, intake temperature, intake pressure. So one will see. So figure shows the compression ratio. This graph shows the compression ratio. Here temperature versus compression ratio. Here ignition delay in, that is the degrees, number of degrees versus compression ratio. So the increase in compression temperature of the air with increasing the compression ratio also increases. If you see here, as compression ratio increases, the temperature also increases. Temperature also increases. It also results in minimum atto-ignition temperature. Minimum atto-ignition temperature. Here also if you see, as compression ratio increases, the delay period in terms of the crank degrees, that will going to be reduces. Getting? So the increase in the compression temperature as well as decreasing the minimum atto-ignition temperature decrease the delay period. Getting? So increase in the temperature, reducing the or minimum atto-ignition temperature results in a minimum delay period. Getting? So that is about the compression ratio. So one can also ask, then why we don't use very high compression ratio in CI engine? Why we don't use the very high compression ratio in CI engine? Why it is in between the only the 12 to 20, not beyond the 20 or not beyond 22 only? So there is a practical disadvantage for a very high compression ratio is that the mechanical efficiency tends to decrease due to increase in the weight of the engine parts. Getting? Engine parts weight is going to be increased, and that will tend to reduce the mechanical efficiency. Therefore, the engine designers always try to use the low compression ratio, which helps for easy cold starting and light load running the high speeds. Then parameter will discuss the engine speed. That is the engine speed. So here ignition delay in terms of millisecond, engine speed in RPM. So delay period, that is again in terms of absolute time or in terms of crank degrees. Here in the graph it is shown in terms of millisecond. So if you see, if the engine speed increases, what happens? Engine speed increases, the delay period in terms of millisecond reduces. Getting? Delay period in terms of the millisecond reduces. Getting? Reducing the delay period in millisecond. However, the degrees of crank travel, the delay period increases. Getting? Degrees of crank travel, the delay period increases as the engine operates at higher RPM. So if engine is operates at higher RPM, the delay period in terms of the crank travel, crank rotation in degrees increases. In terms of time, millisecond, it decreases. Getting? But as we know that the fuel pump that is will be geared with the engine, and the amount of fuel injected during the delay period depends upon the number of crank degrees, because the crankshaft is going to operate the fuel pump, and if the number of degrees of the fuel that crankshaft is to be increases, means which is geared with the fuel pump. This crankshaft is geared with the fuel pump, means more amount of fuel is to be injected in that case. Getting in that case. So delay period in terms of the degrees, it is a increases, but in terms of the millisecond it is a decreases. Getting. So for our consideration, for our importance, that is a delay period in terms of the degrees is a increases with the increasing speed. That's why the CI engine is having the higher speed is not allowable for the CI engine. Then engine output. So with an increase in the engine output, the air fuel ratio decreases. Operating temperature increases, and hence delay period decreases. Getting. So delay period engine output. Then injection timing. So again, if you see here injection timing, that is the pressure versus crank angle. So here it is shown that start of the injection, it is whether it is 9 degrees before TDC, 18 degrees before TDC, or 13 degrees before TDC. Getting 9 degrees, 18 degrees, or 27 degrees. If you see here, if it is 9 degrees before TDC, the pressure rise is after number of degrees, so many number of degrees after TDC. If it is 18 degree, then it is near about the TDC. If it is 30 degree, it is before TDC. Means whatever the pressure rise, again it is a steep pressure rise, high pressure rise. So here we are going to choose the moderate pressure rise, that is at the 18 degrees. It is 18 degrees before TDC. Getting. So it is shown in this figure. So the injected quantity of the fuel per cycle remains constant. In this case, the injected quantity of fuel per cycle remains the constant. So the optimum, we have to choose the number of degrees between this 9 to 30, 18 or 20. In this physical diagram, in stage of combustion, we will show the 20 degree. Then quality of fuel. Which quality of fuel is used? Means certain number of the particular fuel. Getting. So the physical and chemical properties of fuel is also very much important. Physical that or chemical properties of fuel is very much important for the delay period. So the most important property is the chemical that delay. That is the chemical delay property. So is it its self-ignition temperature, which will give us the self-ignition temperature of that fuel. So the lower the self-ignition temperature, lower the delay period. Lower the self-ignition temperature, lower the delay period. So certain number of the fuel is important. Here certain number of the fuel is to be very important. So certain number, if you see here, 30 number cetane, 40 cetane number, 50 cetane number. So here again, if you see here the moderate, that is a 40, where you can got the almost high pressure at the TDC only, not before TDC or after TDC, near the TDC. So likewise, we have to compromise for the again the delay period. So delay period for again 50, it is a lowest, and pressure is also smooth and maximum. Getting. So that is, in this case, the quality of fuel is also very important. Getting. So chemical delay or chemical properties as well as physical properties of fuel is very much important. Chemical properties means that is a self-ignition property of that fuel is very much important. Physical, that properties means how fuel is to be volatile, viscosity of fuel, surface tension of fuel. Getting. Because this viscosity is responsible for better atomization, correct, and volatility is responsible for the rapid evaporation. So in this way, this viscosity and volatility, that is the physical property, also very much important for better atomization and better mixing or better evaporation of the fuel. Next, that is the intake temperature. So delay period is reduced. If you see here, delay period is reduced. Getting. Delay period is to be reduced in terms of the angle, the number of crank degrees. As temperature increases, delay period also decreases. Similarly, the pressure. As temperature increases also, that is the pressure. So increasing intake pressure or supercharging reduces the auto ignition temperature, hence reduces the delay period. Getting, so it also reduces the delay period with the increasing the pressure. These are the different that parameters, important parameters which are going to be influence on the delay period. In turns, it will be influence on the combustion. In turns, it will influence the performance of the engine. Getting, so we will see next lecture. Sorry, again here one chart is to be shown increasing these variables and effect of delay on delay period and their reasons. So increase in certain number of fuel, what happens? Delay period reduces because it will reduces the self ignition temperature, that is a chemical property. Injection pressure, if we increase in injection pressure, better atomization, correct? Better atomization means the better automation and better evaporation, means it will reduces the delay period. Injection time in advance reduces the delay period. Compression ratio increases, delay period reduces. Intake temperature increases, delay period reduces. Temperature increases, delay period reduces. Fuel temperature increases, delay period reduces. Intake pressure increases, delay period reduces. Load decrease or increase the operating. What happens? The load decrease, increase the operating. Getting, so that also going to decrease the delay period. Engine speed increases, delay period also reduces in terms of millisecond, but in terms of crank, what happens? It increases. Getting, in terms of the crank angle, it is a increases. So these are the summary of the different that variables which will impact on the delay period. Thank you. The next that contents we'll see the for the next lecture. So hope you are getting all these points. Rise if any doubts or any problems are there during the lectures.